Hey folks, this is our set 2 of applications in our conics chapter. This one's dealing with elliptical areas. So uh, let me go back first, you guys. Here's our board problem for my, oops, the bells are going to ring here. So I'm here before school, and that's the morning bell before we have a 0 period. So anyway, solve the linear quadratic solution, and so your answer is 2, 1. I'm going to go over that in class. But that's prior knowledge, and I want to spend more time doing this application. I don't know how long this is going to take. So here we go. When lightning strikes in the elliptical region where the strike most likely hits can often be identified. So suppose it's determined that there's a 50% chance that a lightning strike hit within the elliptical region shown. Okay, so there's no XY axes right here, so let's just make this go right through the origin right here. So let's write an equation of this ellipse. Okay, so it's always nice to just pretend like it goes through the origin and everything. We can get equations a lot easier that way, and then anyway, so remember, elliptical equations are x squared over a squared plus y squared over b squared equals 1. Do you remember that? Okay, and so our A's and B's are, this is A right here, this length right here. So if it's 400 going across, then this is going to be 200. So A is 200 right here. And then B, this is 200 going down right here. So this is B right here. Remember, since it's a horizontal ellipse right here, then the bigger number is going to go underneath the X and the smaller number. So this is the vertices right here. So this 200, 0, and negative 200, 0, and then this 0, 100, and 0, negative 100, because remember, this is 200. This is the co-vertices right here, okay? And so the foci are on the x-axis right here, but it's not asking us to do that. So there we go. So 200 squared is 40,000, and then 100, because 200 divided by 2 is 100. 100 squared is 10,000. So there's our equation right there. All right, so then the second part says that the area of this ellipse is pi times a times b. So let's find the area, okay? So this is going to be the exact area, and then we'll see we're going to do some approximating areas here in a little bit. So here we go. So the area is going to be pi times a is 200, b is 100, and so we get around 62,800 square meters. And so since these are in meters, and about 60, almost 63,000 square meters where that lightning strike hits, okay? All right, so we're going to take that equation and solve it for y. I clicked it once too many times. So here's this equation. So I subtracted this quantity from both sides, and then we're going to multiply by 10,000 right there. And so when we multiply by 10,000, we get y squared equals that, and then y equals the square root. Don't forget your plus or minus right there, okay? So let me go back. It's plus or minus because in this picture, here's the plus part, y equals all the plus part, and down below the x-axis is all the minus part right here. So it's plus or minus all of that, okay? All right. So now we're going to graph the first quadrant of that ellipse. Okay, well remember it went up to 100 right here and it went over to 200 right there, okay? So I'm going to make my little scales going by 20, so 20, 40, 60, 80, 100, so it's going to be right there, and then it's going to go elliptically down here, so down to 200 right there, okay? All right, so try to draw your best ellipse right there. And you'll see why in just a second. So try and draw a nice one there. So now we're going to draw rectangles, each of width 40, and that has a height that's equal to the y value of the ellipse at the rectangle's left edge. Okay, I'm going to have one more bell after this, you guys. So here we go. We're going to draw a rectangle with width 40. So I'm going to go ahead and draw it down here. Okay, so a rectangle of width 40. And then I'm going to draw another rectangle of width 40. Now it says the heights of these rectangles have to equal the y value of the ellipse at the rectangle's left edge. So let's draw one right here. So there's one. So the height is this 100 right here. Okay, this is the left edge of the rectangle right here. So the next left edge is going to be right there where the ellipse hits that rectangle. So it's going to start right here and go out to here 40. Okay, so I just so the next one is going to start right here and then go over here 40, and the next rectangle is going to be right here. So it's at the left edge is going to be the height of these rectangles right there. Okay, that's the last bell. All right, so there's that one, and then there's that one, there's that one, and then one more right there. Okay, now what we're going to do is do a little bit of geometry right here, base times height. So base times height is going to be the area of this rectangle. Base times height is going to be the area of this rectangle. And so we have 5 rectangles, and we're going to find the approximate area by finding the areas of these 5 rectangles. Okay, well, we know that these bases are all 40s. That's 40, that's 40, 40, 40, 40. We just got to know the heights, you guys. The heights are the left edge. So the height of this rectangle is 100. That's easy. But what's the height of this rectangle or the height of this rectangle? And so what we got to do is we need to use that formula that we just calculated, the y equals, the plus or minus. And since we're dealing in quadrant 1 only, we don't need that plus or minus part. We just need to worry about the positive part. So we're going to calculate all the heights by plugging in the x coordinates of each rectangle's left edge. Okay? All right, we already know that this height is 100 right here. Okay, this height right here, we're going to plug in x equals 40 right there. So we're going to plug in 40 squared divided by 4, and we're going to subtract that from 10,000 and then square root that. And then we'll plug in x equal 80, so it would be 80 squared divided by 4, and then we'll subtract that from 10,000 and then square root that. Okay, don't let it scare you. That's easy. It's just calculator crunching right there. Okay, and then we're going to do, you know, this x value is going to be 120. So to get the y value right here, the height, we plug in 120 squared divided by 4, subtract it from 10,000 and square root it. Okay, so they're all those x values. We're just going to plug them in. So x equals 100. We already know that. X equals 40. X equals 80, 120, 160. Okay, we don't need to worry about this one because we only want this left edge right here. Okay, all right, so when you do that, our calculators give those y values right there. So those are all the y values. So each rectangle is going to be base times its height, and then this is going to be base times its height. All of them are base 40s, so it's going to be 40 times all of these. Okay, so when we do that right there, 40 times all of those, let me slide that up right there, we get that. Well, what does that mean, you guys? Well, remember, it's in meters, so this picture was in meters. So this little quadrant right here is 17,188 meters squared. Okay, so we're going to multiply that times 4 because there's 4 equal pieces right here. So we get 68,800. Okay, all right, so remember what the exact area was. So we're going to compare this answer with section A, which is our exact answer, and explain why this is the way it is. Okay, well, section A, we got 62,800. So it's 6,000 square meters more, and it's greater because we use rectangles that were larger than the actual size. Let's go back to that right here. Right there. Come on there. Okay, so see how these rectangles are all a little bit larger, so the area is going to be a little bit larger. And this is only in the first quadrant, so we did all 4 right there, okay? All right, so what if we did rectangles of width 40, but instead used the heights of equal to the y values of the ellipses at the right edge of the rectangle? Okay, so at the right edge, what do you think what that answer might be? Was it going to be more or less? Well, I think it's going to be less, more like 6,000 square meters less. I think it's going to be more than that, actually. In fact, if we did that right here, it's all these pink rectangles, and we're doing all the right edges. So the right edge of this rectangle is 0. So that's why this little rectangle has height 0. So there's 40, and then see, here's the first rectangle. We started right here, and it's the same height as the last height of the second rectangle, which is 98. This is the same height of the last rectangle on the third rectangle. Okay, so I'm using these same numbers, except it's going to be 0 right here. So it's all the heights of those. So if we add all those up, multiply it times 4, it's 10,048 square meters less than the actual area because we did more. Now this is what you're going to be doing when you start exploring your calculus stuff here. So what if we did the left side again, but instead used rectangles that had width of 20? What do you think the answer would be like? Okay, do you think it's going to be more or less? Do you think it's going to be more accurate? Well, width of 20 is going to be right there, so we're using the left side again, so this height would be 100. Okay, and so the next one is going to be right there, and so this height is going to be, it's not going to be that 98. We're going to have to plug in x equals 20 this time into that equation to get your height right there, and then multiply it times 20. Remember, this is 20 times the height, so 20 times 100, this one's easy. This is going to be 20 times whatever this height is, and so the next one's going to be 20 times that height. Then we just keep going, and look, there's less error factor, so it's still going to be more, but it's going to be a little bit more accurate right there. When you guys get into calculus, all of a sudden it'll start doing widths of 20 or 10, widths of 5, widths of 1, widths of infinitely close to 0, and you can get it closer and closer and closer and make these error factors much less, and you can get what's called limitations and calculus stuff right there. So then you just find the heights of all those rectangles where x equals on 20 meter intervals. Remember, we already had half of them from the other problem right there. So the rest of that's for your homework right there. And speaking of your homework, that would be your assignment. Take care.